Hello everyone. In this video we are going to solve the problem number 1.28 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A small body is thrown at an angle to the horizontal with the initial velocity v0. So let us say we are having the horizontal direction represented as x-axis and this is the vertical direction, and the body is thrown at with the velocity of initial velocity of v0, which is making an angle of alpha with the horizontal direction. Now here we can write the initial velocity vector as v0 cos alpha I cap plus v0 sin alpha j cap. Okay, and as the body is moving in the vertical plane, so that acceleration can be represented as the g in the negative y direction. So the acceleration vector can be represented as the g vector, that we can equate it to minus g into j cap. Now in the first problem it is asking to find the displacement of the body as a function of time or as a function of t. So let us say the displacement vector r t is equal to initial velocity vector into t plus half into acceleration vector into t square. So finally the displacement vector we will get it as v0 vector into t plus t square by 2 into g vector. So this is the expression of the displacement vector. Now in the second problem it is asking to find the mean velocity vector averaged over the first t seconds. Okay, first of all we can see that the acceleration vector is constant. Acceleration vector is constant because if we see here, the magnitude of the acceleration is constant and the direction is always in the minus y direction. So that's why both the magnitude as well as the directions are constant. So the acceleration vector is constant vector. If the acceleration vector is constant, in that case we can write the average velocity vector is equal to initial velocity vector plus final velocity vector whole divided by 2. Initial velocity vector we know that is equal to v0 vector, and the final velocity vector we can find it using the velocity vector at any time instant of t, that is equal to initial velocity vector plus acceleration vector into t. So from here average velocity vector we can get it as v0 vector plus v0 vector plus g vector into t whole divided by 2. So from here we can write the average velocity vector is equal to v0 vector plus g vector into t by 2. So this is the expression of average velocity vector we got. Now coming to the second part of this problem, it is asking to find the mean velocity vector over the total time of the motion. So let us say the total time of the motion is tau. Total time of the motion is tau. So we can write the final velocity vector is equal to initial velocity vector plus acceleration vector into tau, that is the final time. The initial velocity vector is v0 vector plus acceleration vector into tau, and the initial velocity vector we know that is the v0 vector. So in this particular expression, if we find the average velocity, we can write it as the initial velocity vector plus final velocity vector whole divided by 2, but we don't know what is the value of tau. In order to find this particular value, we have to analyze the motion of the body. So let us say this is the x-axis and this is y-axis, and the particle or the body is starting from this particular point and it is moving in the parabolic path. If we analyze carefully, the initial velocity magnitude and the final velocity magnitude will be same, that is equal to v0 from the energy conservation principle. But we can clearly see that both the direction are not same, both the directions are different. So we can write it as the magnitude of initial velocity vector is equal to the magnitude of final velocity vector, but the velocity vector is not equal to final velocity vector because both the directions are different. So if we write the final velocity vector equal to initial velocity vector plus acceleration vector into time, so we have to find out such equations where we have the scalar quantity of both the final velocity and the initial velocity. For that, let us first see that, let us say we are having the acceleration vector, let us say some vector we are having a vector, okay, and if we consider the dot product with itself, then we will get a square. So if we see these are two vector quantity, and when we are taking the dot product, it is becoming the scalar quantity. That is what we want. So let us take the dot product of the final velocity vector by itself. So we can write it as initial velocity vector plus g vector into tau dot product with the same vector, that is initial velocity vector plus g vector into tau. So we can equate it as vi square plus v initial vector dot product with g vector into tau plus g vector dot product with initial velocity vector into tau plus g square into tau square. Okay, so this is the final velocity square. Now initial velocity, final velocity both are equals to v naught, so let us equate it to v naught square is equal to v naught square plus v naught vector dot product with g vector into tau plus v naught vector dot product with g vector into tau, because both the g vector dot product with the initial velocity vector or the initial velocity vector dot product with g vector both are same, plus g square into tau square. So this will get cancelled. So finally we will get 2 v naught vector dot product with g vector into tau plus g square tau square is equal to 0, and from here we will get tau is equal to minus 2 times v naught vector dot product with g vector whole divided by g square. So this is the expression of total time we have got. Now we have to find the final velocity. So final velocity we can write it as the initial velocity vector plus g vector into total time. So here we can write initial velocity vector plus g vector multiplied with minus 2 times v naught vector dot product with g vector whole divided by g square, and the initial velocity vector we know that is v naught vector. So if we find the average velocity vector, we can write it as initial velocity vector plus final velocity vector whole divided by 2, that is equal to v naught vector plus v naught vector plus g vector times minus 2 v naught vector dot product with g vector whole divided by g square whole divided by 2. So from here we will get v naught vector minus g vector times v naught vector dot product with g vector whole divided by g square. So this is the expression of the average velocity vector we will get. I hope the entire procedure is clear. Thank you.